Hello, Math 20-1s. We've been dealing with quadratic equations and how to solve them. Today we're going to look at a specific part of the quadratic formula, the discriminant. So, we know what the quadratic formula is. We know how to use it. If I look closely at it, I notice that this b squared minus 4ac, the radicand, will help us determine the nature of the roots of the quadratic equation we're trying to solve. So by nature of the roots, we mean the following: whether the equation has real roots or not, and if it has real roots, whether they are different or whether they are equal. So the expression b squared minus 4ac is called the discriminant of the quadratic equation that you're trying to solve. It discriminates among the three cases that can occur, and we'll look at those three cases right now. So if you're asked to solve x squared plus x minus 6 equals 0, looks like we can't factor it. Nothing adds to 1 multiplies to negative 6. We could complete the square, but we've learned that if I complete the square in general, I get the quadratic formula. So let's use the quadratic formula here. So substitute in a is 1, b is 1, c is negative 6. If I work through this then, 1 squared minus 4 times 1 times negative 6, so 1 squared plus 24. Under the radical sign, I'm going to get 25. This value is the discriminant. I notice that 25 is obviously greater than 0. Let's see what happens if I write the solutions in. Negative 1 plus or minus 5 divided by 2. So negative 1 plus 5 is 4 divided by 2 gives me 2. Negative 1 minus 5 is negative 6 divided by 2 gives me negative 3. So my solutions are negative 3 or positive 2. That means we've got two distinct real roots. If I look at the graph of the corresponding function for this equation, in other words, if I let 0 equal y and graph it, it will have two x-intercepts. There are two distinct, different real roots. There are two x-intercepts of the graph when the discriminant is greater than 0. Let's look at another situation. Let's solve this equation. Again, nothing multiplies to 1 and adds to 2, so we can't factor it. We'll use the quadratic formula, a being 1, b is 2, c is 1, substitute into the formula. From here, if I work inside the radical sign, 2 squared is 4, subtract 4 times 1, which is 4, so 4 subtract 4, I get a value under my discriminant, which is, or under my radical sign, which is 0. So the discriminant has a value of 0. If I work this out, negative 2 divided by 2 is negative 1. Doesn't matter whether I add or subtract 0 to that. So I'm going to actually end up with negative 2 plus 0 divided by 2, negative 2 minus 0 divided by 2. I'm going to get two values that are the same. So we say that there are two equal and real roots. And if I draw the graph of the corresponding function to this equation, if I let the 0 equal y and graph the parabola, I'll notice that the vertex, the turning point of this parabola, is on the x-axis. There is only one solution. It only touches the x-axis at one point. They call that two real and equal roots. Okay, let's look at the third situation. Again, I want to solve this quadratic equation. If I use the formula, a is 2, b is negative 3, c is 8. Substitute into my quadratic formula. And I work under the radical sign. Negative 3 squared is 9. 4 times 2 times 8. That's 64. 9 subtract 64. We get a negative 55 under the radical sign. So my discriminant is less than 0, negative 55, less than 0. I can't take the square root of a negative number, so I will have no real roots, only imaginary roots. If I were to draw the corresponding function, letting y equal replace 0 here, I would get a parabola that never touches or crosses the x-axis. So it doesn't have any x-intercepts. There are no real roots. We say there's only imaginary roots. So we can make the following conclusions. If the discriminant b squared minus 4ac is greater than 0, there should be two different real roots. If the discriminant b squared minus 4ac equals 0, there are two equal real roots. And if b squared minus 4ac is less than 0, there are no real roots. We could say there's two imaginary roots. Now that we know this, let's use the idea of the discriminant to figure out the nature of the roots of this quadratic equation. So I'm not asked to solve it. I'm not going to find the value of x that makes this thing true. I'm just looking to figure out whether there are two different real roots, two equal real roots, or no real roots. So I'm worried about the discriminant. So let's just work out what b squared minus 4ac equals. So b squared minus 4ac, b is negative 12, I square that, minus 4 times a, which is 4, times c, which is 9. So negative 12 squared is 144. 16 times 9 is also 144. So I get b squared minus 4ac equals 0. I look at my little conclusion chart up here. When the discriminant equals 0, there are two equal real roots. Those are the nature of the roots. That's all this is asking us. Tell me about what the roots or solutions are going to look like. Well, they're going to be two equal roots that are the same, real and equal. All right. Let's try this one. Again, we're just worried about the discriminant and decide which one of these three cases occurs. So plug in b is negative 2, a is 1, c is 3 into our discriminant, b squared minus 4ac. b is negative 2, a is 1, c is 3. I get 4 subtract 12, which is negative 8. When your discriminant is less than 0, there will be no real roots. So that's all they're asking. Determine the nature of the roots. For this question, this equation, we would say there are no real roots. Now determine the value of k for which the equation has each of the following possibilities. So I've got this quadratic equation, x squared add kx add 4 equals 0. What value of k will make the equation have equal roots? Well, we know from the last slide that when our discriminant b squared minus 4ac equals 0, we would have two equal roots. So let's use that information. To have equal roots, our discriminant must equal 0. So let's substitute a is 1, b is k, and c is 4 into this equation, and now let's solve for k. So k squared, that's our b value, minus 4 times a, which is 1, times c, which is 4. So I get k squared minus 16 equals 0. If I want to solve that equation, I add 16 to both sides, and I take the square root. So k would equal plus or minus 4. Anytime you take the square root, include the positive and negative. So in order to have two equal roots, this equation would have to have a k value that is either positive or negative 4. All right. Part B. What value of k will give us two distinct real roots, two different real roots? Well, again, using our discriminant b squared minus 4ac, we know that for this case to occur, the discriminant must be greater than 0. Then we'll have two distinct and real roots. So I'm going to use the same b values, k. I'm going to use the same a and c value because it's the same equation. So if I plug in k for b, 1 for a, 4 for c, I'm going to get this k squared minus 16 again. So k squared minus 16 now is greater than 0. How would I work this out? Well, k squared has to be greater than 16. So what you want to think is, what values of k, if I square them, will give me a value greater than 16? Think a little bit and you come up with k should be greater than 4 or k should be less than negative 4. We could write this as the absolute value of k is greater than 4. So any value of k that is greater than 4, if I square it, I'll be greater than 16. If it's less than negative 4 and I square it, it will be greater than 16. So there's a solution for when the roots would be two distinct real roots. You could write it like this: the absolute value of k is less than 4. Let's look at the third situation. No real roots. In order to have no real roots, the discriminant must be less than 0. So again, we know that k squared minus 16 would equal 0 if I plug in the values for b, a, and c into my discriminant. So k squared should be less than 16 now. So just like up here, we ask ourselves which numbers when squared produce a result that is less than 16. Now, what numbers would be less than 16? So I think of it and I would say, well, the numbers that when I square them would be less than 16 would have to be between 4 and negative 4, right? So 3, 2, 1, negative 3, negative 2, negative 1. So I write that as k is greater than negative 4 but less than positive 4. Or I could say the absolute value of k is less than 4. All right, that's all we got for today. Work on these questions next day in class. We'll talk to you guys then.